half of the gold that comes out of the ground is used to make jewelry. Another big chunk is used to make gold bars and coins. We've been using gold in this way for thousands of years. But recently, researchers have been experimenting with using tiny amounts of gold in technology and medicine. In the future, you could be drinking water cleaned by gold, heating your home with solar cells that contain gold, or taking gold medicines. Gold makes good watches, rings, and coins because it's inert. It doesn't really react with oxygen, so it stays looking nice and shiny. It's actually a pretty boring metal from a chemistry point of view. But zoom into the nanoscale and gold gets more interesting. This gold nanoparticle is the size of a virus. At this scale, it's easy to manipulate and harness the surface properties of gold. For example, molecules like drugs can be attached to the surface with the help of sulfur atoms, which can form covalent bonds with gold. The gold can then carry these drugs to where they're needed in the body. Inert gold is a good delivery vehicle because it doesn't react with other molecules in the body. Let's zoom in a bit more. At this scale, gold nanoparticles can be used to exploit a special interaction between light and matter. Because gold is a metal, some of its electrons are free to move around. If just the right wavelength of light is used, these electrons can be made to oscillate all at the same frequency. This special property is called surface plasmon resonance, and it could be used to turn gold nanoparticles into very precise cancer killers. These rod-shaped nanoparticles have antibodies attached to their surface that allow them to bind only to tumor cells and not healthy cells. Once enough of them have accumulated in the tumor, infrared light is used to make their electrons oscillate. The energy from these oscillations spreads to the surrounding area as heat, and this sudden temperature increase kills the cancer cells. But that's not all they can do. Gold nanoparticles of slightly different sizes absorb slightly different wavelengths of light. So by gathering together different sizes of nanoparticles, it should be possible to make solar cells that can absorb more sunlight. Scientists are working on this as one way to enhance the efficiency of solar cells.